Welcome to our lecture for the day, and we are going to be talking about, we're going to start talking about the last of our Earth systems, and we'll get right into it here. So here, not including the sky, we've got the solid part of Earth, and this is what we refer to as the geosphere. Geosphere is, like I said, the solid part of Earth. So when we think of Earth, we tend to think of it as a solid. Now we understand that there's water covering 70% of the surface, and it's surrounded by a sphere of air, but the bulk of our planet is this solid part. That's why it's a terrestrial planet. It has that solid core, and we'll get into all of that actually tomorrow as far as the structure. But let's get a look at a little bit of the makeup of it, and we'll start just by looking at the term geosphere. And as with the others, it is an English word that comes from two Greek words. Remember, sphaira, globe or ball. That's our sphere, our three-dimensional circle. But the first one, we've had this before, ge, and it means earth. So geo, whenever you see geo, it's talking about earth, the earth. So geometry, geology, yes, that's this word, geosphere, ge, and sphaira. So let's talk a little bit about what makes it up, not the actual structure, but what are these structures made from. And so the geosphere, we start out with kind of a thin layer of soil, dirt. We know that this is an important part. This is where a lot of the plants grow and living things live, but we've got this area of soil kind of mixed in with rocks and other things here, and just dirt. And underneath that, though, we have layers of rock. And we've talked about this, the strata, and a lot of this is used to age the planet. And you can see the strata in the rock layers. And there's obviously a lot more than that going on. But this is just kind of an upper part. But there is a layer of soil and rock and layers of rock and stuff like that. So let's talk about our next vocabulary word, is mineral. We're going to hear this a lot, and you've probably heard this word a lot, but let's get an actual definition. Because it matters. We can't just use it generically all the time. So specifically, when we say a mineral, we're talking about a solid that is naturally occurring, inorganic, and has a crystal structure and a definite chemical composition. So every part of this definition is very important. And we know what minerals are. Here's some examples. You've got some quartz and some amethyst, and looks like some pyrite, and all different things here. But let's kind of define what makes up a mineral. So the International Mineralogical Association, which is an actual thing, I looked it up, it has very specific requirements. Just like, remember, we looked at the rules for something being a planet. Here's the rules for something being considered a mineral. So it has to be naturally occurring, a naturally occurring substance. So something that we're going to just find that's not man-made. But it has to be formed by natural geological processes. So that rules out some things that we would consider minerals. By the Mineralogical Association's definition, they are not. There are certain things that are made from organisms. There are certain compounds of calcium and things like that are made biologically, whether from humans or other animals. Those do not count as minerals. Coal. Coal is formed from the remains of animals, fossilized and pushed with pressure down to things like that. So coal would not be a mineral. Now, it fits some of the other definitions, but it's not formed by natural geological processes. It involves biological and geological processes. So we won't count coal as that. Now, it must be a solid substance in its natural occurrence. So when we find it out in nature, it has to be a solid. Now, granted, there are some exceptions to this, but by and large, the vast majority are going to be solids. And you think about it, that's our different phases. We have solid, liquid, and gas. It cannot be a liquid or a gas. It can't be fluid. So it has to be a solid. Third, it must have a well-defined crystallographic structure. So it has to be in a crystal form, or be able to be found in a crystal form. If you look at, got some different examples here of, there's some different crystals here. Go back here. These are found naturally occurring. Amethyst will usually be formed like this. Quartz. Now, if you remember, we looked at some geodes. Some people brought in some pictures. Check those out. Those are crystals inside, and they formed naturally in that shape. And then it must have a fairly well-defined chemical composition. There are, if we look at these, graphite is a form of carbon. Now these list coal, but technically coal is not considered a mineral by that definition. But each of these has a very specific chemical composition. They're compounds of different things made this way, whether of carbon or some other silicates or things like that, but it definitely has a well-defined chemical composition. You're not going to find the same mineral with different formulas, different compounds. Every time we have a certain compound, it's going to be found this way. Now, there are some different variations within that, but it's still going to have, that mineral is going to have a well-defined chemical composition. So minerals are actually rated according to several different properties. We're not going to cover all of them, but I want to just kind of give you some examples of what they are. One is color, but color can't always be used to define what a mineral is, because you can have the same mineral but have it different colors. But what will be the same is the streak. So the streak is the color of a mineral's powder. So when that mineral is crushed down, you're going to get a specific color. No matter what color it was as a whole, when you crush it down, they're all going to be the same streak. Hardness, this is how much it can resist scratching. So you have a diamond, and a diamond is a fairly hard mineral, but then you have something like gypsum. I think we have some gypsum somewhere in here. Gypsum is actually very soft, and you can scratch it with your nails. So hardness is one way that we list separate minerals according to their properties. Then the next is luster, and this is how light reflects from its surface, or how shiny is it. Then there's crystal structure, and this is the orderly geometric spatial arrangement of the atoms. So what shape is that crystal? So again, if you look at these, you have different crystalline shapes, and there's, if you really get into mineralogy or gemology, you can see there's different types of crystal shapes, and they're often separated based on the type of crystal structure. All right, now let's move on. Let's talk about rocks. A rock is a naturally occurring solid composed of minerals, rock fragments, and sometimes other materials such as organic matter. So remember, a mineral can't have any organic matter, but rocks can be formed from organic matter. So coal would technically be a rock, not necessarily a mineral. Now, there's different types of rocks, but rocks are mainly separated into three different types. You have igneous. Igneous is formed when magma cools, magma being lava below the Earth's surface. So while it's under there, it will cool and harden. Also, when it comes up above the surface and it's lava and it cools, that's also an igneous rock. Here's some examples of what igneous rocks look like. You see they're kind of porous there. The next type is sedimentary. And sediments are when rocks erode and they become that powder, whether it's from the wind or from water. And then that sediment settles down either underneath the water or underneath other rock layers, and it gets compressed down and hardens and forms sedimentary rocks. Here's an example, and you can see the layers as it's kind of compacted and compressed underneath the weight of the things above it. And then the last type is metamorphic rocks. And these are formed by extreme temperatures and pressures, changing existing rocks into new rocks. So you take either a sedimentary or igneous rock and it's put under extreme pressure and it heats up and forms a completely new type of rock. So this is the basics, the beginning of the geosphere.